Hey everybody, today we will do another video, and today we will do another video on Laplace transforms, inverse Laplace transform. So basically the idea of the Laplace transform is this little symbol here with f of s, which is equal to the integral of 0 to infinity, and it's equal to e to the at, negative at, and okay, so this Laplace transform in S domain is equal to this integral, right, from 0 to infinity of e of ft, and then of course gotta have a derivative. If you have an integral, you gotta have a derivative. Okay, so now if we do have this, right, so just do a little quick analysis here. If it's equal to 0, this goes to 1, but it goes to infinity, and then it just goes to 0. Okay, that's basically. Okay, let's do this. Okay, so now, so we have this Laplace transform, and this whole thing is normally written as capital F of s. Now, so we now doing the reverse of this. We're doing the reverse. So what we do now is the following. We do Laplace transform inverse of f of s. That's what we do. Laplace transform inverse of that. We have this. This was given to us. Now we need to find the inverse of that, which is going to be in the f of t. So we will getting the function of time back, right? So that's the whole point of it. Okay. So let's get an example. So the example that we're going to do is a problem that it is using the inverse Laplace, not using the table, because you can use the tables, but some complicated cases you have to use the partial fraction decomposition. So the problem statement says find the inverse Laplace transform of the following function. So now the Laplace transform given to us was like this. So f of s in the s domain, right? So we need to find back the time domain is equal to s squared plus 2s plus 1, and it's going to be over s plus 2 times s plus 3. Okay, so that is the Laplace transform given to us. Now, we need to find that. Let me just move this up, because I need some room here. So, okay, so let's copy that on the top here and say, so f of s is equal to s squared plus 2s plus 1, right? In the bottom we have s plus 2 times s plus 3, right? And Now let's start doing the. Okay. So. Okay. Okay. So let's start doing this. Right. So I'm going to write this right here and leave some space. I'm going to say that s squared plus 2s plus 1 over s plus 2 times s plus 3. And over here I'm going to put s plus 2 times s plus 3. And then over here I'm going to write the first coefficient. How many denominators do I have? I got it 1, 2, 3. 3 different functions being multiply each other pretty much here. Okay? So I need A, B, C. So I need A over S plus 2. And then B over S and C over S plus 3. Okay? So notice that I have something here. Right? So I need somehow to get rid of these denominators. This right here. So I need to get rid of this. So I need to multiply by s plus 2 times s times s times s times s plus 3, right? Then again, matter of fact, you know what? Okay, let me write this right here. So s plus 2 times s plus 3, right? Now another one, I need s plus 2 times s times s plus 3. Okay, so notice that I need to start canceling some stuff out here. So the first one I can cancel is this. This right here is gone with that. That cancel with this one. This right here cancel with this one. This right here cancel with that one. Now I need to rewrite this. So I need to say s squared, and of course this over here cancel with that one. So now I am left with just this one. So I am left with s plus 2s, well on this side, right? Plus 1. Now this one gets multiplied with the a. This one right here gets multiplied with the a. This right here, this one and this one gets multiplied with the b. And this one and this one gets multiplied with the c, right? So let's do this. So a times s times s plus 3 plus b times s plus 2, right? Times s plus 3 plus c times s plus 2 times s Now, okay, now we had to distribute this. Distribute this guy, distribute this, distribute this. So s plus 2s plus 1 equal a times x. S times s is s squared. S times this is 3s. 3s. S times 3 is 3s. Right? And plus. Now, s times s is s squared, right? So, times b, and then s times s is s squared. And then this times this is nothing but plus 3s. This times this 2s. 2s. This times this is 6. Okay. Now, last one here. I got c, right? So c s times s is squared, s, and then this times this is just 2s. Now I need to combine this piece inside. I need to do that before I get to multiply it. It's nice. I mean, you could multiply this again and then add inside, but it's easy to make a mistake that way. So s squared plus 2s. Or you can add them. I can just add them too, right? This is 5s and then multiply by that, but I want to do the process you can actually see. So s squared, this right here is going to be a times s plus 3s, a times s squared plus 3s plus b. Now I am adding these two guys. I'm adding this two, right? So these two guys. So now plus b, and inside I'm going to have inside I'm going to have s squared plus 5s, and it's kind of hard to write the s's and the 5s, and then plus 6 plus c s squared plus 2s. Right. Now let me distribute this back here. So I'm going to distribute that, distribute this, and distribute that one inside. So s squared plus 2s plus 1 equal on the other side. I said a s squared plus 3as plus b plus bs squared plus 5bs plus 6b Wait a second. Okay. Only kept that right. Okay, so I guess. Okay. So that is because yeah, that's right. Okay, so now now I gotta do this point. Now I gotta do c plus c C plus C S plus C S squared plus 2CS. Okay, so now I got this, right? Now I need to look at the right, look to my right, and look to my left. What do I have? I got an S squared over here, some terms are S squared. I got an S squared here, another S squared here, another S squared here. I look to my right. Do I have an S squared? Yes, I got an S squared. So I need to equate all my X squared on my right to my X squared to my left, along with the coefficient. The coefficient is A, V, and C in this case. So equate this, so I get S squared is equal to AS squared plus BS squared plus CS squared. That's my first equation. Second equation is, now what do I have? Again, I have another term. Do I have an X and a single S to the one exponent? Yes. I got a few over here. I got that one, and this one. So I got, let me do this in blue. I got this one, I got this one, and I got this one. So this one is going to be equal to 2S equal to 2S is equal to 3AS plus 5BS plus 2CS. Okay, so this is gone, 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 this is gone. What am I left with? I am left with 6B. Right? So I am left with 6B. So I am left with so I got lots of 1, right? So 1 is going to be equal to, I already did the x's, now I'm doing the constants. This is gone, this is gone. So 1 is equal to 6B. So now I have this. So now I can actually solve this for, right? And I get B is equal to 1/6. And I keep that in my toolbox. Okay. Now let me, okay, so now that I have this, I already have one value. So now let me divide everything by S. The square by S squared on both sides. That guy is right there, that's equal to 1. That is gone, that's gone, that's gone. And in this case I get 1, right? Equals A plus B plus C. Now, here the same thing. So I divide everything by S. Divide everything by S. And over here, if I divide everything by S, this is gone, that's gone, that's gone, that's gone, that's gone. So it's equal to 2 equal to 3A plus 5B plus 2C. Okay. As you can see now that I have, let me just clean this up. Okay. As you can see now that I have one value, I already got my B. I already got my B. And I need to do a find A and C. Okay, so let's do it. So I went to write. Okay, so let me just use a little space right here and to do the rest of this algebra. So okay, so I have 1 equal to A plus B plus C, and I have a 2 equal 3A plus 5B plus 2C. The question is, right, I want to eliminate one of them. Which one do I eliminate? Well, that depends on me. Which one I want to do, right? Which one I feel like to eliminate? I feel like to eliminate 2 C in this case. So I'm going to multiply top and bottom by what? I have a positive 2, so I want to get negative 2 over here. So negative 2, right? When I multiply that, I get what? In the top I get negative 2 equal to negative 2A negative 2B and negative 2C at top. On the bottom I keep the same, so I get a 2, and it's equal to 3A plus 5B plus 2C. Okay. And this is very common when you are kind of new in mathematics and you know that something is going, like you say, why did I do this? I thought I was trying to solve a problem, but I got a 0 on my by adding the 2 equations. Don't worry about it. It will work it out. It will work out. So let's get it done. So when I add this is equal to 0, right? This 2. Over here is going to be equal to A, right? 3A minus 2A is A. And over here is going to be equal to 3B. And over here is 0. I'm not going to write it, right? So now this is my other equation. Okay, so now I got that equation plus this one, right? So I am getting there. So what I can do now is, I said 0 is equal to A plus B, right? I know what my A is now, right? I know what my B is, I'm sorry. I know what my B is. So I said, okay, so in this case, actually, it's 3B, right? So 0 is equal to A times what? I will be replacing now, I know where B is, so I'm going to replace B by that. So I'm going to say, okay, 1/6 times 3, right? So now this is what? Right? 1/2. So 0 is equal to A plus 1/2. So for A, right? And A is equal to nothing but -1/2. Now, I got an A and I got a B. All I gotta do is use any of this equation to find my C. So now I got 1 equal to A plus B plus C. Now I do 1, right? And I do that one is going to be equal to -1/2 plus 1/6, right? Replacing A and B, and then plus C, right? So now, what do I have here? I have a common denominator, right? In this case, Now we can talk about denominators and numerators because now we have as fractions, right? Okay, so now let's do this. So let's find the common denominator of this, right? You can actually solve by C doing this way by moving the whole piece and do it right here. Or you can find the common denominator by find the common denominator here, which is 6, right? Multiply by 6, right? And 6, right? And then over here, I don't need the 6 because I already have it 6. Okay, so now in this case, but over here, I need 3. I need 6 right here. Right? So now look at this. And now, of course, it's going to be 6 over 6. Whatever you do on one side, you do it to the other. So now, look at this. So I have 6 equal to negative 6 plus 1 over 6. And this is 6, and this is 6. And this is C. You can say 6C over 6. And you can see that. Now all of these are gone. Gone. You can see that. All the 6 are gone now. Now what do I have? I have 6 is equal to 1, negative 6 plus 1 plus 6C. Add this 2, right? Actually, I made a mistake here. So this one is multiplied by 3. By 3. Yeah. So this one is supposed to be 3. Right? That's supposed to be negative 3. Okay, so you can see now that this is negative 1. This is negative 1, right? So I'm sorry, this is negative 2. You added a negative 2 to here, right? So then, okay, so let's do it. 6 is equal to negative 2 plus 6C, right? Move that to the other side and I get plus 2, and I get plus 2, and I get 8 is equal to 6C, right? Now, divided by 6 on both sides, and I get that C is equal to 8 over 6 or 4/3. Okay? So now, this is my C, right? So now, I got A, B, and C now, all the values. So now I got, this is, C is equal to 4/3, and B is equal to 1/6. Those are all my values. Now I need to put the Laplace transform into time domain. So now, Laplace transform is the following. So because we had a 2, that's going to be, okay, so remember we had like this. So we had s squared over s plus 2 times s, right? And at the top I have plus 2s plus 1. Okay, but over here I had an s plus 3. Okay, look at this. This is a positive, This is over 1. So when I factor this guy, this becomes 1 over. Okay, so okay. Let me take a step back. Over here, this is 1 over s. This is 1 over s. This one is the one that get the earliest number, this one, but this is 1 over s, which is technically is a step function because 1 over s. So that's why. So this one is 1 over s. So a. So c is equal to this. So c is equal to this. A is equal to that one, right? And b is equal to this. So now you can put this in any order, it doesn't matter. You can put this in any order, it doesn't matter. You can put this like this. So you can put Laplace transform of inverse Laplace transform of f of s is equal to what? Is equal to the let's do it this. So this one is going to be a -2. Why? Because it's positive, so it's going to be, and then this one is going to be just over whatever that number, this just right here is. So it's going to be ut, unit step function, over what? Over 6, right? Over this 6. This might be value. Like I said, you can put this in any order, it doesn't really matter. Then -2. -2 goes to b. Right here, right? So yeah, or you can do the reverse too. Doesn't matter. At the end of the day, so as long as you put this number right here, which is just, this is my b, this is my c, so it's going to be something like this. So it's going to be -1/2. -1/2. But that 1/2 multiplied by e by -2, -2t, and this one is going to be equal to plus 1 plus 4/3 e to the -3t. So that's the answer. So this is the answer right here. -2t. This is -3t. Why? Why? Because I have a positive here, and the formula is that is the integral from 0 to infinity of e to the -8t. The 8 over here was positive, but remember the final thought about this is like this. So f of s is going to be equal to, okay, it's going to be equal to 1 over s minus a, right? In this case, s minus a is, in order to get a positive here, you need a value of a -8 over here. You can see that. So that's why we get this. So at the end of the day, what is the answer? This one. That's the answer. And thank you for watching, and I see you in the next video. Thank you for watching.